So now that we know how to compute z-scores, how do we actually use them to solve problems? So our empirical rule told us that 68% of the data is within one standard deviation of the mean. What if I want to know how much data is within a half a standard deviation of the mean, or a fourth a standard deviation from the mean? Well, it turns out we can use something known as a z-score table to solve problems with values that are not exactly 1 or 2 standard deviations of the mean. And so I have up on the screen an example of a z-score table. I want to first show you how this table works, and then we'll solve some problems using it. So let's say I have the z-score 0.72. So I had a raw score, I had a mean, a standard deviation, I computed my z-score, it was 0.72. We can look that number up on this table, and how you do that is you go down to 0.7. So I have highlighted the row that's 0.7 in blue. And then because it's 0.72, you go over to the 0.02. So I highlighted that region in yellow. And where that row and that column intersect is the value that you're going to read off the table. So when I have a z-score of 0.72, this table gives me the number 0.7642. What is that number telling me? That number is telling me the percentage of data that lies below that z-score. So that's how this table works. When you look up a positive z-score, you get a decimal. You can move the decimal 2 places over to write it as a percentage. And so in this case, I know that 76.42% of the data lies below the z-score 0.72. All right, so I want to run through several examples just to get us familiar with using this table. So here's my first example. Use the z-score table to find the percentage of data that lies below z equals 0.62. So I'm going to look up 0.62 on my table. So I went to 0.6, that's in green, and then I went over to 0.02, that column's in yellow. Where those two intersect, I get the number 0.7324, and that is the percentage of the data that lies below that z-score. So I did move the decimal over. My final answer, 73.24%. Now, what if I want to know what percent of the data lies above that z-score? This table gives me the amount of data that lies below that z-score. So we saw in the previous example that 0.7324 that I have circled means 73.24% of the data lies below 0.62. So if I want to know the percentage of data that lies above that z-score, I just have one extra step to take. Well, I'm just going to take 100%, all the data, minus 73.24, and I get 26.76. So if you want to know the percentage of data that lies above a z-score, you just have an extra step. You have to subtract the number from 1 or the percent from 100%. What if we want to know the percentage of data that lies between z equals 0 and z equals 0.62? So z equals 0 is my mean. We saw earlier that when we looked up that 0.62, we got the 0.7324 number that I have circled in my z-score table. So that meant 73.24% of the data lies below that 0.62. But the region below the mean is 50% of the data. So if I want to know what percentage of the data is that region in green, well, I could just take 73.24 and subtract 50, and I get 23.24%. So once again, drawing a picture here, creating a visualization, I think is a really good idea. I think it can help you see what to do. What number are you subtracting? What if we want to use our z-score table to deal with negative z-scores? It turns out we can use the same table, but because a negative z-score is below the mean, that means our table is now going to give us the percentage of data that is above a negative z-score. Okay, so to summarize, if you have a positive z-score, the table gives you the percentage of value below that. If you have a negative z-score, the table gives you the percentage of data above that. So you can use the same table to solve problems with negative z-scores. So what percentage of the data lies above z equals negative 1.21? I can actually just look that number up on my table. So I went down to 1.2, over to 0.01, and I got 0.8869. So that would be 88.69%. We can also solve problems where we want to find the percentage of data that lies between two z-scores. So in this case, I want to find the percentage of data that lies between z equals 0.82 and z equals 1.33. So I'm going to start by looking up each of those z-scores on the table. So 0.82, there it is. I got 0.7939. And then the 1.33, I got 0.9082 when I looked those up on my table. So I'm going to draw a picture. So basically, both of those are positive z-scores, so they're both above the mean. So I drew my bell curve. 0.82 is above the mean. 1.33 is also above the mean. The numbers from my table are giving me percentages below that value. So this 0.7939 tells me that 79.39% of the data lies below 0.82. And then my 0.982 tells me that 90.82% of the data lies below 1.33. I want to know the percentage of the region I shaded in green between those two z-scores. And so I can just subtract those percentages to get my final answer. So final answer, 11.43% of the data lies between the two given z-scores. Finally, what if we want to find the percentage of data between a negative and a positive z-score? So I want to find the percentage of data between z equals negative 1.2, so that's below the mean, and z equals positive 0.38, that's above the mean. So I've drawn my picture. I'm going to look both of those numbers up on my table. 1.2, that's 1.20, corresponds with the 0.8849. That's what I get in my table. 0.38 corresponds with 0.6480. Okay, so when you look a positive z-score up in the table, it gives you the percentage of data below that. So I know that 64.8% of the data lies below 0.38. But when you look up a negative z-score on the table, it's giving you the percentage of the data above that value. So 88.49% lies above the 1.2. So if I want to know the percentage between those two values, there's a couple ways to do this. What I'm going to do is, because I was given a negative z-score, that 88.49 gives me the percentage above that value. So I'm just going to subtract that number from 100% to get the amount below that value. So 100 minus 88.49, I got 11.51%. And now I can solve this problem exactly like I solved the previous problem. I can take my 68.4, I don't know why I keep saying that number backwards. I have it written on the screen right. I can take 64.8 and subtract 11.51, and I have circled my final answer, 53.29%. So this is a quick overview of how we can use z-scores to get percentages of data. And this is all in normal distributions. But sometimes we might be asked to work backwards. So, for example, let's see if we can now find a z-score such that 30% of the area under the normal curve is above that score. So I'm going to draw a picture. So we are looking for the z-score that corresponds with this line I've drawn. Let me highlight it right here, this line, such that 30% of our data lies above that z-score. So that means 70% of that data must lie below our z-score. And so we're working backwards. We're trying to find the z-score. And so I'm going to just scan the middle of this chart, looking for something that is exactly 0.7 or as close as I can get to 0.7. So I'm just looking at the numbers in the middle. And there we go. It flips to 0.7 right where I've circled. I've got a 0.6985, 0.7019. Which one of these is closer to 0.7? I would say the 0.6985 is closest to 0.7. And so what is the z-score that corresponds with that value? 0.52. So z equals 0.52 is the z-score that corresponds with 70% of the data being below it and 30% of the data being above it.